Hi there, my name is Paul and this is Exposure Therapy. In this video, I'll teach you about one of the most fundamental concepts in photography, the photographic stop. The stop is ubiquitous, it's everywhere, and understanding it will make you an efficient photographer. However, to learn why the stop is so vital, we need to establish a foundation of knowledge about the basics of exposure and reciprocity law. These will be our first topics, so let's begin. Exposure is the total amount of light used by your camera's image sensor to make a photo. It has a direct influence on the brightness of your pictures. The total exposure, that is the volume of light received by the image sensor, is determined by two factors: the intensity of light passing through the lens and the time duration of that exposure. The following equation shows this relationship. Exposure equals intensity multiplied by time. The aperture controls the intensity of light. It's a variable-sized circular opening found inside most lenses. Meanwhile, the shutter controls duration, being the accumulation of light over a period of time. On your camera, the aperture and shutter are the only settings for controlling the total amount of light reaching the sensor. A third element, called ISO, is an electronic function that simulates changes to exposure but without adding or subtracting light. In other words, adjusting the ISO changes the brightness of your pictures without changing the exposure. Together, the aperture, shutter, and ISO control what I call the effective exposure, that is, the brightness of your picture. It's expressed using the following equation. Effective exposure equals intensity multiplied by time multiplied by ISO. These equations reveal a common bond between the exposure controls. Reciprocity represents the relationship both intensity and duration have on the resulting exposure. That's because many combinations of intensity and duration can produce photos with identical exposures. Even more combinations of intensity, duration, and ISO can make photos with the same effective exposures. To get a better sense of reciprocity, let's take a moment to consider pure math. Consider the number 100. It's the product of 50 times 2. But it can also be the product of 25 times 4, 20 times 5, 10 times 10, or 2 times 5 times 10. There are many different equations that equal 100. The same principle applies to light and photography. Several combinations of aperture and shutter speed can produce the same total exposure. For example, you can achieve the same total exposure using an aperture value of f16 and a shutter speed of 1/250th seconds, or f11 and a shutter speed of 1/500th seconds, or even f5.6 and 1/2000th second shutter speed. All three permutations produce equivalent exposures. Students attending my beginner courses get this concept quickly but question its usefulness. What's the point of making these adjustments if the exposure remains unchanged? The point is artistic. Although the primary purpose of the aperture and shutter is to regulate exposure and picture brightness, they have secondary characteristics that can change the artistic appearance of your photograph, giving it a distinct character. If you're happy with your exposure in terms of brightness but not in terms of the depth of field, say you want more dramatic focus separation, you can increase the size of your aperture. This change increases the light intensity passing through the lens, raising the exposure and making your picture brighter than originally intended. To compensate, you'd simply select a faster shutter duration. The change decreases exposure by the amount equal to the change you made to the aperture. It seems easy, right? You've made a change that added one quantity of light, and then you subtracted an equal quantity of light to balance the exposure. However, there's a complication. Different units of measure express your exposure settings. F numbers express the aperture, time units express the shutter speed, and ISO is a unit itself. So how do we reconcile changes between F numbers, duration, and ISOs? We do it with the photographic stop, which unifies everything. In photography, a stop is a unit that describes the change or difference between exposure values. Adding one stop doubles your exposure, but subtracting one stop halves your exposure. Therefore, a stop multiplies or divides your exposure by 2 depending on whether you're adding or subtracting light. And remember, multiplying by half is the same as dividing by 2. You can add or subtract multiple stops. For example, adding 2 stops doubles your exposure and doubles it again, which creates an exposure 4 times brighter than the original, because 2 times 2 equals 4. Conversely, subtracting 3 stops halves your exposure, then halves it again, and halves it a third time, which creates an exposure that's 1/8 as bright as the original, because half times half times half equals 1/8. The photographic stop reconciles how changes to the aperture, shutter speed, and ISO affect the balance of exposure and picture brightness. Virtually every camera shows a degree of change applied to each setting using stops or fractions of stops. You can check this on your camera right now. Grab your camera, select Shutter Priority Mode, and rotate the command dial to adjust the shutter speed. By default, most cameras will make a 1/3 stop change to the value for every detent or click of the wheel's rotation. So, for example, if you start at 1/500th seconds and rotate the dial by 3 clicks towards the faster direction, you'll arrive at 1/1000th seconds. These two values differ by 1 stop. -1 stop if moving from 1/500th to 1/1000th, because that change halves the light, and adding 1 stop if moving from 1/1000th to 1/500th, because that change doubles the light. Now try it with F numbers. Set your camera to aperture priority mode and count the clicks between f8 and f16. It's 6 clicks on most cameras, representing a change of 2 stops, because each click of the wheel applies a 1/3 stop change. Whether the shift is plus or minus 2 stops depends entirely on whether you're adding light by moving towards lower F numbers or subtracting light by moving towards higher F numbers. In practice, these changes won't affect your exposure because both priority modes are automatically exposed. The camera balances your inputs by automatically applying an inverse transformation to the setting it controls. However, your camera can sometimes misread the scene and produce poor auto exposures. You can fix these errors with auto exposure compensation, which lets you raise or lower the standard exposure set by the camera. A numeric scale expresses changes in exposure compensation, and the change to exposure between each adjacent number is 1 stop. Most cameras allow you to adjust the exposure compensation from ±2 to ±5 stops in 1/3 stop increments. Note that some camera makers refer to the numbers expressing exposure compensation as EV. EV stands for exposure value, and in this sense, they're synonymous with stops. Understanding the concept of photographic stops is essential when setting exposures manually, and lets you quickly determine the ideal balance of the aperture, shutter speed, and ISO. Let's pretend we're outside on a sunny afternoon and want to capture a portrait. We can quickly obtain a good exposure by using the Sunny 16 rule of thumb. It states that we can get an accurate exposure in direct sunlight by setting our aperture to f16 and selecting a shutter speed that inversely matches the ISO value. Therefore, ISO 100 would correspond to a shutter speed of 1/100th of a second, and ISO 400 would match with a shutter speed of 1/400th seconds, and so on. Let's take this rule of thumb and apply it to that daylight portrait. Our starting exposure values are f16, 1/200th of a second, and ISO 200. However, portraits generally benefit from a shallow depth of field because it creates a visual separation between the subject and their background, and an aperture of f16 isn't ideal for this goal. Let's choose f5.6 instead because it accomplishes the effect and is achievable by most lenses. It takes 9 clicks of the control dial to move the aperture from f16 to f5.6, and this translates to a 3-stop increase in light intensity. If we were to take a picture now, our exposure would be 3 stops, that is 8 times, too bright. Since our change to the aperture adds light, we must subtract an equal amount of light from the remaining values to balance our exposure. To remove 3 stops of light from the shutter, we must turn the shutter control dial 9 clicks to the faster direction, which results in a shutter speed of 1/1600th of a second. Thus, we replaced our starting exposure values of f16, 1/200th of a second, and ISO 200 with f5.6, 1/1600th of a second, and ISO 200. This change adds 3 stops on the aperture and subtracts 3 stops from the shutter speed, which makes the net difference 0. It imposes a dramatic visual change without altering the effective exposure. Now let's see what happens when we add ISO to the mix. Reset the camera to the original rule of thumb setting, f16, 1/200th second, and ISO 200. We'll again choose f5.6 for the shallower depth of field. However, we'll now split the balance between the shutter and ISO. We'll subtract 1 stop from the ISO by moving from 200 to 100. This makes our picture 1 stop darker. To remove the remaining 2 stops of light from the shutter, we'll turn the shutter control dial 6 clicks towards the faster direction, resulting in a shutter speed of 1/800th of a second. Thus, we've replaced our starting exposure value with f5.6, 1/800th of a second, and ISO 100. This change adds 3 stops of light on the aperture, subtracts 2 stops of light from the shutter speed, and removes 1 stop of brightness from the ISO, creating a net difference of 0 stops. The underlying notion of stops, the act of multiplying or dividing by 2, is ubiquitous throughout all facets of photography beyond adjusting exposure compensation and balancing manual mode. For example, stops express the output power of built-in and external flash units. The output power on my ProPhoto D1 is adjustable in full stops or in 1/10th stop increments. Stops also indicate how much light is lost to color, polarizing, and neutral density lens filters and light modifying gels. Camera makers use stops to specify the effectiveness of optical and in-body image stabilization systems. And once the camera and lights are off and you're in the digital darkroom, editing applications like Adobe Lightroom and Capture One Pro use stops to represent the scale of their exposure adjustment sliders. This shows that stops are inescapable. Reinforcing your understanding and internalizing the knowledge through practice will help you become an efficient photographer. And all it takes is knowing how to multiply or divide by 2. I hope you enjoyed this video and found it helpful. If you have requests for future topics, let me know in the comments and I'll consider them for future videos. In the meantime, you can learn more about photography or join my group photography courses in Toronto by visiting exposuretherapy.ca. See you next time.